atom, it is absorbed by the atom, and your electron will make the transition from the ground state to the excited state, right? And that process is known as the absorption. In this, your electron goes from the ground state to the excited state. So whenever your external photon interact with the atom, you can see the construction or the basic atom structure here. The black one is your nucleus, around which you have orbits, in which the red color are the electrons. So whenever you have a external photon which is incident on the atom, it is absorbed, and your electron make the transition from ground state to the excited state, and that particular process is known as the absorption. Now after this, your excited electron can come down to the ground state via two different processes. One is a spontaneous and the second one is a stimulated. Right. So this is your spontaneous. So this is again the first is the absorption. Your electron goes in the excited state, but your electron cannot remain in the excited state. So it will come down automatically to the ground state and emit the photon by E is equal to h nu, where h nu is your band gap. So there is a spontaneous emission. Okay, whenever your electron make the transition from the excited state to the ground state without any external photon or without any external energy, such emission or such emitted photon is known as your spontaneous emission. Spontaneous emission is basically automatic emission. You don't require any external force. Your electron will come down from the excited state to the ground state without any external force. Next is your stimulated emission. In this, again, your external photon make the already excited electron to come down to the ground state, and due to this you have two photons in the output, one which is the incident photon and the second one which is your emitted photon due to the transition of the electron from the excited state to the ground state. We can see this again. This again you concentrate on the one electron which is already in the excited state. Now that excited electron, it is not coming down automatically, it remains in the excited level. Now when your external photon is incident, right, Einstein had said that your external photon can stimulate that electron to come down. So here your external photon makes that electron to come down, right, and due to that you have two photons in the output, one which is the original photon which is external photon, and the second one which is the red one which is emitted due to the transition of the electron from the excited state to the ground state. So in this you have two photons. So stimulated emission, in that you have two photons, one which is the original one and the second one due to the transition of the electron from the excited state to the ground state. Now there is a small difference between the spontaneous emission and the stimulated emission. Spontaneous emission takes place automatically, you don't require any external photon in that, but in your stimulated emission you require the external force or the external photon to stimulate or to force the excited electron to come down. Now next is third is your amplification. We all know amplification is basically it is to amplify something, right? So amplification is the act or the means by which you can increase some physical quantity. Either you have a sound, voltage, current, electricity, anything. The process in which we are going to increase something, that particular process is known as the amplification. Now in the laser we have the light amplification by stimulated emission of radiation. So in this we are going to amplify the light, right? So we are going to, how we are going to amplify the light? So light intensity, we are going to amplify the light intensity. So if you want to amplify the light intensity, we are going to increase the number of photons, because intensity is the number of photons. So for light amplification, we need to increase the light intensity, that is number of photons. So if we increase the number of photons, we can increase the light intensity, and we can say that we have amplified the light, right? So the purpose of the laser is to amplify the light intensity. So in this, we are going to increase the light intensity by increasing the number of photons. Now we have seen that in your stimulated emission, in the input you have a 1 photon, and in the output you have a 2 photons. So in that stimulated emission, you have amplified the number of photons. In the input you have a 1 photon, and in the output you are going to have 2 photons. So that's why you have increased the number of photons. But in the stimulated spontaneous emission, you have in the input you have 1 photon, and in the output you have only 1 photon. So in your spontaneous emission, there is no amplification, but in your stimulated emission, you have a amplification, that is your number of photons are increased. So in the next point, we can see that we have already discussed that we can see that in the stimulated emission, there is an increase in the number of photons. So for amplification of the light, we require the stimulated emission only. We cannot amplify the light in the spontaneous emission. So that's why we have a light amplification by the stimulated emission of radiation. We don't have the light amplification by the spontaneous emission of radiation, right? So for the amplification, we require the stimulated emission. Now the next point is a population inversion. We have seen that in the stimulated emission, we require the excited electron or the atoms. We require the electron already in the excited state, right? Now how this excited electron can be achieved? So that comes in your 4 point, that is the population inversion. The normal population of the electrons in any energy level given by this equation, n is equal to n0 e raised to minus capital E by kt, where n0 is the number of electrons in the ground state, capital E is the energy level, k is the Boltzmann constant, and T is the absolute temperature. So if we have a energy level E1, if we consider the two energy states with the energy E1 and E2, the number of electrons in the energy state E1 is given by N1, that is equal to N1 is equal to N0 e raised to minus E1 by kt, and the number of electrons associated with the energy level N2 is given by N2 is equal to N0 e raised to minus E2 by kt. So N1 and N2 are the number of electrons associated with the two energy levels E1 and E2. So if your E2 is greater than your E1, then from the mathematics we can see that your N2 will be less than N1. That is, as the energy increases, your number of electrons associated with that energy level decreases. So as you go from the ground state to the higher state, your number of electrons associated with that energy level decreases. So that we can see in the normal distribution, that is a normal population. Okay, E1, E2, E3, that three sets are shown, and your red color or the red dots are the number of electrons. You can see that you have a more number of electrons in the E1 state. As you go to the E2, the number of electrons decreases. Then in your E3 it is less. So as you go from the ground state to the excited state, your number of electrons decreases. So that is a normal population. But in some situation or in some case, if you reverse this condition or reverse the situation, then that particular process or that particular situation is known as the population inversion. In the normal population, we have more number of electrons in the ground state, and we have a less number of electrons in the excited state. Now if we have a mechanism so that we can reverse this equation or reverse this condition, that is, we have more number of electrons in the excited state as compared to your ground state, such is known as the population inversion. That is thus. In the next slide, you can see that you have more number of electrons in the metastable state. So even as a ground state, E2 is the metastable state and E3 is the excited state. So in this we can see that we have a mechanism so that we have a more number of electrons in the E2 as compared to our E1. Right. So you have achieved this population inversion. That is, you have more number of electrons in the excited state as compared to your ground state. So such situation is known as the inversion. That is, we have inverted the whatever the normal condition. So that is known as the population inversion. Now the question is, how we can achieve this? Because normally whenever your electron goes to from the ground state to the excited state, it cannot remain in your excited state. So after 10⁻⁸ seconds it will come down, right? But if we have in practice, the population inversion is possible when there is the existence of the metastable state. The metastable state is the state which has the more stability. So if you mix some particular materials, it will generate some intermediate state which has the more stability as compared to your excited state. The excited state has a lifetime of 10⁻⁸ seconds, while your metastable state has your lifetime of 10⁻³ seconds. So your electron can remain for 10⁵ times more in the metastable state as compared to your excited state. So metastable state of energy has the lifetime of 10⁻³ seconds, which is 10⁵ times more than the lifetime of other higher states. So your electron can remain in the metastable state for the longer time, so that you can accumulate the electrons in the metastable state, and you can achieve the population inversion. That is, more number of electrons in the metastable state as compared to your ground state or the lower level. And due to this we can have a stimulated emission, and due to that we can have a amplification. The next point is a active medium. Now basically active medium we can have in your electronics. We have active components, the components which can amplify something. Such component is known as the active components. Like transistor is a active component which can amplify. Your resistance as well as your capacitors are known as the passive components. So the component which can amplify is known as the active components. Similarly, the medium which can amplify, here we are talking about the amplification of the light. So the medium which can amplify the light, such medium is known as the active medium. So the active medium is the solid, gas or any solid state medium which has the metastable state, which can create the population inversion and which can amplify the light. Right. So the medium which has the metastable state can create the population inversion and can have the stimulated emission and can generate the amplification of the light. So such medium is known as the active medium. So the medium which has the metastable state is known as the active medium. Then the next point is the pumping. Basically pumping is the same phenomena. The external energy is used to pump the electrons from the ground state to the excited state. Right? It is the same concept of the water pump. We use the water pump to take our water from the ground state to the excited state. So here your electron, your external energy makes the electron from the ground state to the excited state. Right. So if you use the external energy to take your electron from the ground state to the excited state, such process is known as the pumping. So the process in which the external energy is consumed to make the electrons or atom to undergo the transition from the low energy state to higher energy is known as the pumping. Right? It is the same that we use the pump. There are two types of pumping. One is the direct pumping and the second one is the indirect pumping. The direct pumping is also known as your primary pumping, and indirect pumping is known as the secondary pumping. The direct pumping, if the external energy which is used to excite your electron interact directly to the atom which is to be excited, then such pumping is known as the direct pumping, right? So if you have a external energy, and if you want to excite this atom, and if your external energy directly interacts with this atom and excite this electron, then such kind of pumping is known as the direct pumping. So in the direct pumping, you have your external energy or the external photon interacts directly to the atom which is going to be excited. Such type of pumping is known as the direct pumping. We can see again the further same one. The external. Next is your indirect pumping. When external energy interacts to the atom which is to be excited via intermediate atom, such kind of pumping is known as the indirect pumping. So here we can see this. Your external photon interacts with the atom X, it is excited, and it interacts or it collides with the atom Y, and it transfers the energy to the Y, and now your Y is excited. So we are going to use the intermediate atom to excite the another atom. So we now in this indirect pumping you have three components. One which is the external photon, second that is the intermediate atom, and the third one which is the atom which we want to excite. So your external photon interact with the atom, that atom excited, and that excited atom collide with the another atom, and that collision makes the energy transfer, and due to which your another atom is excited. So there is an indirect process in which you have an intermediate atom also. So there is an indirect process or the secondary pumping. Now your direct pumping has also, we can divide into three different categories. One is optical pumping, second is your electrical pumping, and the third one is the direct conversion. So first we can see the optical pumping. If the luminous energy, that is light, is supplied as external energy to the medium to cause the population inversion or to take the electron from the ground